right, welcome back. This is we're gonna use trig to find missing side lengths today. But first, here is how we usually remember sine, cosine, and tangent without needing to leave page 7 open all the time. SohCahToa, which sounds, yes, it sounds like SohCahToa. Bear with me here. Okay, this is a mnemonic, which means it stands for things. So this first part means that sine of an angle equals opposite over hypotenuse. Do you see that in here? Let me get a highlighter. Oh no. Okay, so S for sine, right? O for opposite, and then H for hypotenuse. So sine equals opposite over hypotenuse. Sine equals opposite over hypotenuse. Okay. We can do the same thing for ka. Get in the ka. Ka stands for that cosine of an angle equals adjacent over hypotenuse. So same format. Cosine is adjacent over hypotenuse. Oh my gosh, I'm so sorry. I was petting my cat and I'm allergic to her. But I can't say no. Tangent equals opposite over adjacent. Okay, so SohCahToa is how we remember sine, cosine, and tangent. And it's universal. I didn't make this up. Whenever I ask anybody who's like adult-ish, you know, like an adult kind of, about trigonometry, they go, oh, SohCahToa. That's all they remember is SohCahToa. They don't remember what it means most of the time. But ask an adult. They won't know what trigonometry is, but they'll know that SohCahToa is something that they learn. It's really fun. It's cute. I like it. All right, and then I found that the best way to teach this to you is just to show you a million examples. So instead, I'm going to show you 3. Because that's all the space I have. Maybe 4. Maybe we'll get 4 in. Okay. So for this one, again, we're gonna identify the things that we know and the things that we don't know and the things that we have, right? So this is my angle that I'm gonna use. So this is where my perspective is from. This is where the little dude is. Okay. So that tells me that if this is the angle, this is my theta. This is the hypotenuse. This one is the opposite side. And then this is the adjacent side. Okay. So I, at 26 degrees, want the opposite and I know the hypotenuse. So the adjacent has nothing to do with this problem at all. Nothing to do with it. So out of SohCahToa, which one is useful in this problem? Well, because I know the opposite, sorry, I want the opposite and I know the hypotenuse, I'm going to use I'm going to use sine. Because cosine will either need or want the adjacent side, and tangent also either needs or wants. I can't have 2 unknowns. I don't know the opposite or the adjacent, so I can't use cosine or tangent. I'm going to use sine. So then we set up our proportion. This is a ratio. Sine of this angle is a ratio. It's some amount. We don't know what it is. But guess who does? Our calculators. So sine equals opposite over hypotenuse. So sine of 26 degrees equals x over 14. Do you need this step? No, I'm just showing you every single little piece of this. Okay. Now, here's who knows sine. Actually, let me show you something kind of fun first. Hold on. Okay. Trigonometry's been around since long before calculators. So they used this to do pyramid stuff in Egypt, in ancient Egypt. So they have these tables with every single sine ratio on it. Not all of them. This is just the main ones. So 26 degrees is on here. Hold on, I have to scroll down. 26 degrees, this is the sine at 26 degrees, is 0.438. But if I wanted 26.3, I would have to use this table instead, which is intimidating. All right. But, oh, Geico, sorry, this is not sponsored by Geico. So We could use this. Actually, I had a student who preferred using tables over calculators or electronics, and I just appreciated it. I don't have my book right now. I don't know where it went, but I have a book of like a bunch of these. So what we're gonna do, it says we're gonna use our calculators. So I only know, actually I know more than this, but on my Android, which I currently have, we have to rotate it sideways. And then look, sine, cosine, and tangent are right here. So on an Android, I need to do sine 26. Look, it's 0.438, just like this table said. On an iPhone, you have to do 26 and then push the sine button. And if you have a yellow calculator, because you check one out from the library, we would do sine 26. Wait, that's a different number. Yes, it is. Now, here's the deal. If your phone or your calculator is not giving you the 0.438 that we said, it's because it's in the wrong mode. So do you see up here how it says rad? That's important right now. It's the first time it's been important ever. So I have to go to mode and change it from rad to deg, because radians is a algebra 2 pre-calc level stuff, and degrees is what we use in geometry. Okay, so we're going to try again. There we go. There's the right answer. And on your cellular device, it'll say like deg or rad somewhere. So this turns on radians, and then I press degrees and it turns off radians. So degrees is the basic mode for your phone usually. Please email me if you have any specific questions. I will help you with your, like, take a screenshot of your calculator and email it to me. Like, however you do it, I will help you, because this is the part where I usually walk around the classroom and make sure everybody's calculator is saying the right thing. So any calculator, I will help you. Email me. So sine of 26 is 0.438. I'm going to write a note in here that we got that from my calculator, because I only know a couple of them by heart. It's not sine of 26 degrees. 26 isn't common enough for me to have memorized it. So sorry. So there's my thing. This is an algebra problem now. It's a gross algebra problem because there's a fraction involved, but it is an algebra problem. So in this specific case, because 14 is on the bottom, I'm going to multiply both sides by 14. Why did I do it with a dot or with that? I don't know. Because that will cancel out this. So I get 6.14. All right, we like rounding, but we don't like rounding too soon. So we usually want to keep 2 decimal places. Not 2 decimals, but I ran out of room, so hopefully you understand that. So I don't really want to do like 6.1371 whatever. I like to round it to 2 decimal places, because any shorter than that is too short. That's me. That's not a math in general thing. That's just 2 makes me feel comfortable. Because I'm weird. It's fine. Also, if you need rounding reminders, again, email me. I'll help you out. I'll give you all the. It's like a train. I think of it like there's like a boost that I see a picture of. Like if you skipped that day and then you never really understood rounding because of that. It happens. Okay, so here's my little dude, because I'm at the angle that I know, right? This is the angle that I'm working with. I don't know this one. I can't use this one. This is my angle. So here's my opposite. Here's my hypotenuse. And then this is the adjacent side. Okay, so this is the decision that, this is the part that confuses people the most, is which one do I use? So here's the deal. I know the opposite and I want the adjacent. So hypotenuse has nothing to do with this. So out of SohCahToa, which one am I going to use? Well, opposite and adjacent is TOA. So I'm going to use tangent. I'm not going to use sine or cosine because they both have to use the h, and I don't want to deal with the h. It doesn't exist and I don't need it. All I need is this one. I don't care about this one. We kind of care sometimes, but okay. So tangent. So tangent at the degrees equals opposite, which is 22, over adjacent, which is x. Okay. So I need to figure out what tangent 61 is. So I go ask my handy dandy calculator. And I say, hey, calculator, what's tangent of 61. And it goes, well, it's 1.804, obviously. So again, that came from the calculator. Oh, sine and cosine will always be less than 1. Tangent is the one that could be bigger. And the reason that sine and cosine are always less than 1 is because it's got the hypotenuse involved, and the hypotenuse is always the longest, so the other sides are always shorter. That's why. So I know that this is actually going to be bigger than that one. So I should have drawn my triangle a little bit differently, but who cares? It's the math that matters. It's not the triangle drawing. I'm not an artist. I am, but it's fine. Okay, so here's the fun part with this one. X is on the bottom. So here's what I have to do. I have to multiply by x on both sides. So I get 1.804x equals 22, because that cancels, right? Cancel out the bottom top. And then I divide by 1.804. I personally just switch these two in my head. I cheat, and that's okay, because that's what I'm doing. You can just swap these two and you'll get the same answer. But I'm showing you why. Okay, so I get x equals, I don't know. I'm confused because I said it was going to be bigger and it's smaller, but you know what? It's fine. I'm not going to erase anything. I'm not going to pretend like I knew. So I get 12.9. So that's the side length of x. 12.19. It's fine. It's okay. Oh, also, if you're, I'm keeping all 3 decimal places here. If you're chopping it off, you'll get a slightly different answer, and that's okay, but I would use 3 decimal places as I'm doing it, and then 2 when I'm done. Just as a rule of thumb. Okay, let's do one more. I'm really mad that this is kind of a curvy line, but it's fine. It's okay. Okay, same thing. We're going to identify where I'm standing. I'm standing at the angle. Here's my theta, right? So this is the hypotenuse. This is my opposite side because it's across from where I'm standing. And this is the adjacent side. Okay, so I know the hypotenuse and I want the adjacent side. So opposite has nothing to do with this. So out of SohCahToa, I want the A and the H. I want cosine. So not sine and not tangent. And yes, I wanted to do one that was all 3, so you could have just guessed that, but don't rely on this, okay? So cosine of 35 degrees. Sometimes I do degrees, sometimes I just write the parentheses, sometimes I just didn't write that. It's fine. Cosine equals adjacent, which is x, over hypotenuse, which is 53. So I'm going to ask my calculator nicely what the heck cosine of 35 degrees is. And it says, well, by golly, it's 0.819. And I say, thank you, calculator, because we always respect the things that give us life. And then I have to multiply both sides by 53, because 53 is on the bottom. I have taught enough geometry that I know somebody in their house somewhere thinks that whenever it's tangent, we do weird stuff. Whenever it's sine and cosine, we just multiply. That's not how this works, okay? 0.42. It's not how this works. I can show you 6 total problems. 2 of sine, 2 of cosine, 2 of tangent. And I can show you that some of them we multiply, some of them you do this kind of switchy thing. Okay. It just depends on what's missing and where x is. So if x is on the top, we multiply. If x is on the bottom, we swap them. Basically, we swap these two. In other words, we multiply and then divide. That's what we're doing. That's just what happens. I can do that for any single type of problem. Challenge me, I dare you. Okay. That was long because I showed you a lot of work and did some rambling, but I hope this helps. Excuse me. Email me if it doesn't. Goodbye.